functions, all the things were covered in Power Query, and we have seen how to append the queries. If you have if you want to add row wise data, we go for append. If you want to add some column wise data, we go for merge. And if you want to have a group data, we go with a group by. And we have done like some of the number functions, some of the text functions, and some date and time functions. So we have done all this in Power Query yesterday, and we have seen what is column profiling also. In column profiling, we have done column distribution, column quality, and column profile also. If you look at the Power BI flow, so basically we start with Power Query. That is, first we go with get data. Let me write it here. Get data. Once your data is in your Power BI desktop, we go with ETL. We do transformation in Power Query. Then after transformation is done in Power Query, we load the data into Power BI desktop, and then we enter into the second step, that is your data modeling. Okay. Then in data modeling, we do add modeling and we do some DAX. Then third step is your visualization, or I can write it as report building. Report building. Report building. So just a minute, guys. Now we are going to see like more about data modeling, and we are going to see what is add modeling and all those things in this session. Okay. So let me open. Okay, guys. So when it comes to data modeling, so without proper data model, you cannot be truly successful in Power BI. That is very sure shot. So what is data modeling? You need to understand it very carefully here. Please be attentive in this session. So when it comes to data modeling, that is like, so imagine that you have a single table. You have a single table and you have many columns in that. Maybe more than 70-80 columns are there in this single table, and there are lot of duplicate values here, and there are more than suppose 10,000 rows in this. So your data model is a big size, it is of big data, and you are dealing with only a single table. So now you are having a single table with 70 plus columns, let us imagine, and there is more than 10,000 rows in this. Now imagine that you have pulled this table into your Power BI. So now you have pulled this table in your Power BI. Now you start working on this. When you started working on this, your Power BI engine is designed in such a way that it will be more efficient when you start working on a multiple tables, small multiple tables, not in a single table. It will be not so efficient if you are working on a single table. So Power BI engine works on, or it will be more efficient when you have a schema, a specific schema on that table. It is not recommended to have a single table. So we should have a schema for that. So what type of schema it should have? So most of the time it should have a star schema from your table, or you should have a snowflake schema. This is very rare, but I'm just telling you there are two types of schemas that we can have in our Power BI. So Power BI engine loves when you import the data in star schema. If you do not have a star schema data model, if you are having only a single table, you can split this single table into multiple small tables with this complete single table. So let us imagine you have 70 plus columns. So maybe 15 columns in this, 10 columns in this, 8 columns in this. So basically we are reducing the size of this single column. So from single column we are dividing that into multiple columns, and the final agenda will be that we create a star schema. So now what do you mean by star schema? We are going to see that in next slide. So data modeling is all about getting a good model so that your Power BI engine will work more efficiently, and it will give you all the correct results and correct visuals when you have a proper data model. So in this case, it can be a good star schema data model. So star schema means you will have one fact table, sorry. So star schema is, it will, you will have fact table, one fact table and surrounded by multiple dimension tables. I'll give you the best example for this. So in fact table there will be the facts or the events recorded, and in dimension table the details of this fact are shown in this dimension table. Here you find all unique values. There will be more duplicates in this. We will be seeing some example on how the star schema looks and what like how fact table and how dim table looks. So basically when we import the data, when we get the data into our Power BI desktop, we import it with a star schema only. If we do not find that table with a star schema, then we create a star schema in our maybe Power Query. We can do that in a Power Query, or we can do that by using a DAX. Okay, most of the time we do get a star schema model. We will do some changes on that. If we are done with that changes, then directly we like go on building the reports and visuals on top of that. If your model is not perfect, if your model doesn't suits a star schema, then we have to create a star schema out of that by using any of this method. And while building a star schema, we need to look on the relationship. This is very, very important. So in a layman's language, it is called relationship, but in Power BI's language, it is called cardinality. Cardinality. So what is cardinality? That cardinality is a relationship between the two tables that can be a fact table to dim table. So what type of relationship do we have between these two tables? We are going to set up all that into cardinality. And one more concept on this data modeling and one in model is cross filter direction. Cross filter direction. So I'll be talking more about cardinality, cross filter direction, water relationship, everything in this session. So now if you are talking about a single table, so as I have told you, this single table is divided or divided into multiple small tables, like from single table to many table, so that the final outcome would be like you get a star schema. So this is your fact table and this is your dim table. Dim table, dim table, dim table, dim table. So this is how your fact and dim table looks like, and you can call this as a star schema. It looks like a star schema. Let me show you some examples on how and what are your some examples on star schema modeling. Okay, to explain you the data modeling, suppose let us imagine that I have a table. Suppose I have a table of my institute. For just an example, I have an ID and I have student's name. I have student's last name, and I have his email address, I have his phone number, and I know like on which course he has registered, his course ID, and what was this course name actually, and what was the course course duration, and I will also have duration. I'll also have what was his course fees. Okay, the details of all course fees. And let me push this all after this. Let me take date of enquiry, enquiry, date of registration, date of joining or batch date, batch start date, and status, that is fees paid or not, yes or no, fees paid or no, or like let me take it as fees, only fees, amount. Okay, amount. So these are all the columns I have. Let us just have an example. So I have like mostly 13 14 columns here. You can see. Let me increase this, let me increase this. I can have n number of options. Again, I can give a location, I can take his address, his pin code, and let me take two more records. So I'll say that date of enquiry and batch start date. Let me take this here, and batch start month, and I have something here, something here. I can say that day of enquiry. So on which day I got more enquiry, I want that also. And I have a pin code, I have an address, and all these things. You can see, you can add 10th mark, 12th marks, is degree, everything, all that. Now, just imagine that I have student ID 1. Suppose his name is Sachin, for example, and suppose Sachin Tendulkar, and his email address is sachin@mail.com. His mobile number is 123, and he has come for the enquiry on maybe 1st of October 2022. It was, let me check just a minute. It was on Saturday. 1st October was on Saturday, and day of registration, he has done registration on 3rd of October 2022, and batch start date was also on the 3rd of October 2022. Batch month, sorry guys, it is 10 year, it is 10 year, and batch start month was October, and fees was suppose 10,000, and he has registered for course. Oh, this is actually number. Yeah, so course ID is 1, course name, suppose he has registered for Power BI, duration is 1 month, and course fees is 10,000. He has paid, suppose, okay, let me take 5,000 here, 10,000, and the course fees is 20,000. Okay, his location is Mumbai, and pin code is suppose 411101, and let me skip the address. Okay, now without wasting much time, let us imagine that I have suppose 1,000 students registered, 1,000. Okay, 1,000 students registered. Now just imagine that for this 1,000 students registered, so many values are repeating here. So just imagine you have ID 2. Let us do fast calculations now. Let us type it fast. Suppose Virat Kohli, and his email address is suppose virat@gmail.com. Number is 234, and he has also come with the same inquiry, same day registration. He also come with the same month. He also paid the same fees, but he has registered for big data, for example. Okay, big data, and course duration is 3, and the course fees for big data is 40,000, is from Delhi, and pin code is 11101, something like that. Okay, now let us imagine you got one more candidate, and it is Rohit and Sharma. He may have different email address like r@g.com, and his number may be 4. He has also come on the same day. He has also registered for the same course, big data course. The duration will be same, and the fees will be same, and he is from different city, and the pin code can be different. Now, if I say you that there were 1,000 students who have inquired on this date, first date, okay, so you will end up getting 1,000 records with the same date, with the same day. Registration date is also same, batch start date is also same, and month is also same. Just imagine how much data we are creating and how much size of the data increases because of this repetition. So this is your single table. That is what I am talking about. If you have a single table like this, what you can do with this single table? So with this single table, you need to like break down into multiple tables. So how can you do that? So you cannot just take few of the columns and put that into a new table. You cannot do that. So there might be some logic. That logic is nothing but you are doing a data modeling on that. So what I'll do now, so instead of these 4 IDs you can see here, so you have course ID, you have course name, you can cut course duration, course fees. So let me make a new table, and I'll call this as a course table, and let me copy this like course ID 1. Let me copy 1, 2, 3, this 4 tables and paste it here. Now I will delete this. Yeah. So I can see that I have only 2 courses. So first course is of my Power BI. The duration is 1 month and the fees is 20,000. Second course is my big data. The duration is 3 months and the course fees is 4,000 or 40,000. Now I can easily remove this all columns from here. I will delete this. Now you can see the size of your data model has been reduced drastically. Now you might be surprised like, okay, then where is my, what do you mean by course ID 1? Okay, not to worry. Course ID 1 means, okay, come here. Course ID 1 means Power BI, duration, fees. What do you mean by course ID 2? Okay, course ID 2 means it is course ID 2, it is big data, it is of 3 months and the fees. Now imagine that there are 1,000 people, those who are coming for the inquiry or those who are coming for the registration. Let me scan this, and they will be registering for the course 1 or 2 or 1 or 2. So now if you are filling these all, it is so simple that with one column you can understand that, okay, what do you mean by course ID 1, what do you mean by course ID 2. Even if I want to add something, the details of the course, like tools covered in Power BI, I can do it with only 2 rows, guys, with only 2 rows. You can see that. I can say that Power BI is covered in this, SQL is covered in this. If I come and say that big data, I can say that Python is covered in this, Python is covered, SQL is covered, Spark is covered, Cloud is covered, and so on. Okay. So this can be our tools that are covered in big data. But if imagine if these 4 columns would be in the same sheet, you would have end up getting this 1 to 1 to 1 to 1,000 times you would have get Power BI big data, Power BI big data, Power BI big data, and then this would be the repetition, this would be the repetition, this would be the repetition. So To avoid such repetition, we create a data model. So I can call this now as not only course table, I can call this as a dim course table. Now when you have repetition, you can see you have a repetition 1 2 1 2 1 2. This is all repetition created. I can call this as my fact table. This is my fact table, this is my dim table. Now you might ask me a question like, so here we have 4 5 tables. So depending upon the scenario, you can have one fact table, or you can have two fact table, you can have three fact table, you can have n number of fact tables. So now in this model, whatever we have done, we have only one fact table. Let me show you. Yeah, so we have one fact table, and from that we have only one table. We can create other dim table also. We can create one more table by using a date. Just a minute, guys. Yeah, sorry for that, guys. So you can create one more dim table out of that. You can create other dim table out of that. By depending upon the requirement, you can do that. So let me show you how you can create. So let me do it quickly. Now you have a fact table. You have all the details of this date. So let me pull out all this and copy it somewhere. And I call this as a dim date and paste it somewhere here. Let me put all this. Now I can see that the when it comes to date of inquiry, all the details are shared here. I can write it here. Let me add a few more columns here. Okay, what was the year, what was the month, what was the month, and what was the day? For example, what was the day? So it is 2022. It is day 1. Sorry, it is actually general. I need to change the data type, and the month was 10. Okay, let me cook this to general. Yeah, so I will sorry I will put this copy to all this. Now you might be thinking like each and every record is same in this. Absolutely, all the records are same, so why you want these two? Just delete this. Okay, if that would be in the fact table, and imagine that there are 18 candidates who are coming on the same day, so you would have copied all this 18 times. Oh. But now what you can do now, instead of copying all this, you need to just delete all this, delete 4 records. Now what is 1st October 2022? Okay, come to dim date, I will show you the details. So 1st October 22 was the 22 year, day 1, 10th, it was Saturday, then the registration was this one, and so on, so on, so on. So you have reduced your data model from 17 18 columns to only 7 8 columns. This is how a fact table looks like, and this is how your dim table looks like. So when we pull that into a data model, I mean in Power BI, you will understand it more clearly. Yeah. So this is a understanding of how your data model from single table you can convert it to a multiple tables or many tables, and that many tables will be your star schema. Let me go to the next slide. So if you are talking about single table, and many will ask you a question like, what if I have a single table, if I load that into Power BI, will it get a correct results? Can I do a report on that? Obviously you can do that, but there are some limitations to that. If you have 1 million rows or less than that, you can go with a single table. If you have more than 1 million rows, then obviously you have to go for many tables. So it is simple to build a single table, but for developing a many tables, we require a deep understanding of data modeling. And when it comes to scalability issues, like if your data is continuously in stream, when it is updating continuously, you cannot take a single table, then you have to come to your many tables only. And it will definitely run out of the performance issues when you are working on a single table. But when it comes to performance issue, over the large data set also, many tables perform well. So this is a difference, and we always recommend you to use a star schema like Power BI engine always recommends you to use a star schema, use a data modeling out of that, using rather than using a single table. So these are like few differences between your fact table and dim table. So let me just show you few of them. Yeah. So you can see that uh, the fact tables are based out of your observations or events, whereas your dimension table is out of your like describes the observation, like what are the details of this observation. You can see that in this table. So just now we have seen like course id 1 was here. The details of this course can be seen in the dim table, and here we can have more columns, here we have less columns, and the aggregate analytics columns are more in this. And like measurable information are not stored much in this when it comes to dim table. So it holds mostly measurable values, and when it comes to fact table, sorry, dim table, it holds only a textual values. And it has more rows, it has less rows. We have seen that uh, like in our course dim table we have only two rows, course id 1, course id 2, but here we had many rows out of that. So it supports hierarchical creation and it does not support hierarchical creation. We'll see what do you mean by hierarchy. Then it will answer the questions like what, where, when, like textual questions, and it will answer the questions like how much, how many, and so on. So if you're talking about the sales table, your fact table, your observation table, or the events are carried out of this fact table, and you have your price column, you have your quantity column, you have your gross sale, profit, everything in this fact table, and somewhere you have a product column also. The details of the product is shown here, that is product dim table. The details of the date is shown here, that is called as dim date table. And the product of the details of the customers is shown here, that is customer dim table. The resellers detail is shown somewhere here, that is called as a resellers dim table. So this is how your dim table looks like. And if it comes to the fact table, as we have seen, like fact table holds most of the measurable values. If it holds the measurable value, you can answer the questions like how much, how many, and so on. What was the growth rate for the previous years to the current year? By the help of the sales column, you can do that. But when it comes to the dimension table, like what location details for the location ID, Mumbai, and so on, you can ask the questions like this. So this is a basic difference between your dim table and your fact table. Let us do hands-on this. Let us do hands-on. I'll fetch one dataset called as Adventure Works dataset on our Power BI, and we'll see about like how the data looks like in a data model, building a star schema, and we'll see what are the relationship and all those things. Okay.